The first thing you do for the meter is you'll want to make sure you can sign on to it with Modbus RTU. So we hit the E button until we get code, long hold. We're going to select the code 90. It's already there. So we do that with these up and down buttons. So I'm going to go 1, 2, 3, 4, 5, 8, 9. Once we have it, long hold the D button on the left. We'll see that the Modbus address is 1. If you want to change that to something else, that's our default, is 1. You long hold the left button and go into what you want to change it. So you can go to 255. I'm going to set it to 1 and long hold. The next one is Modbus BOD. Use 9600. That's the best one. When you're done, long hold. And over here, the enter will get you back to the normal mode. So I'm going to hit enter again. And now the meter's selected for Modbus. You know it's Modbus slave ID 1, 9600. This left button, long hold. And notice we're changing the third line. We're changing density, pressure, temperature, current, percent, 0 to 100% shown on the top there as well. The frequency, the raw frequency from the vortex shedding, and to show the pressure and the temperature. So we have flow rate, total, pressure, and temperature. Well, this meter has it all. When you start the program up, you're going to be asked to look at this config file. The config file is tfm-vortex.config. If it doesn't exist, copy and paste these elements into a file and name it tfm-vortex.cfg, and you'll have it. Purpose of that is to save the Modbus slave ID and the COM. We'll know the COM by noting what COM port your 485 is connected. This one's COM port 4. That's done with Device Manager. So I'm going to turn that off. Now we should just be able to, once you've got it running, just hit OK. And this is going to go look for that file. Hit OK. Now you can hit the return button or select here after you've made sure you've got the correct COM port. This is the reminder that shows you menu 91. 90 and 91 is how the Modbus settings, and we showed a video how this is done. So you can put those two together. So now we're going to hit this. We're reading variables and variables 2. We'll fill out all the values for each one of these variables, for each register number and each type. And there are many types, and this happens to just be using U8, U16, and IEEE 754 Big Indian A, B, C, D order. I mentioned that A, B, C, D order because if you need to discover more registers, you can select the register you want to look at. Let's look at temperature degrees C. Click read. We'll read that value. We can read that in real time. Here we have milliamps, so temperature degree C. On the graph, right-click, clear chart. You can also on the chart have what kind of update mode you want on the chart. There are 3 different modes. There are 2 lines. One of those is the infinite impulse response coefficient of 0.7 or 70% that will exponentially approach the thing. Kind of looks like a capacitor. And you can set this to 1 to make it 0. You can save the data to Excel that it's been taking. It will spawn Excel, and since I don't have this computer, I'm going to say skip for now and view only and close out all this nasty Microsoft selling stuff. And here's the thing. You could take these 2 columns and filtered one and time, you can have a time history of that. And you can run that as long as you want, and you can set how many seconds in between and select any variable. The purpose of the home is to read all of the real-time variables. It reads these. Every 10th one, it will update these variables. These variables allow you to change the screen, which I showed in the other video, so you can see the screen being updated. And the linearizers for the purpose of making the flow calibration a little more cherry on the low end. Temperature pressure calibration, you probably will never need to mess with this. This is how we calibrate the multivariable flow meter. The RTD is a 100 ohm, and the pressure transducer set up for around 145 psi, whatever that is in bar, and 2 bar, I guess, or 10 bar. And write, this will allow you to write any value that is writable. Of course, you can't write the temperature because it's a read only. And for learning how to convert numbers to decimal, here's single to IEEE, 1, 2, 3, 4, 5, 6, and ABCD, and CDAB is represented like this. And a converter here for your convenience to look how to make an I-16 signed or unsigned. You can see minus 32,768 is 80, and 65,535 is FF. So that's just for helping the folks who have to do the PLCs. That is it.